Alright, in this video I want to talk about graphical relationships and what we're going to do to these particular relationships in order to make them a straight line if they're not already a straight line. And then also we want to focus on how exactly am I going to write a good equation. Okay, so let's say we have some data. Okay, and in this particular set of data of distance in meters versus time in seconds, I get a shape of a graph that looks like this, meaning as time increases, the distance, or the position in this case, does absolutely nothing. Okay, what that means is if we were to use generic y equals mx plus b form, what's on the y? On the y is distance, so I would literally write distance equals, and in this case, this m value, the slope of this, is 0. Okay, therefore 0 times x is simply 0. Okay, and then b would be whatever this number is at that particular point, that y-intercept. So this would have a number, and it would be labeled in units of meters. This is referred to as a no relationship because the distance doesn't change based on time. So if we were taking the perspective of, say, a rock, a really big rock, or a statue or something like that, if we were trying to measure where it was compared to how much time goes by, that rock pretty much just stays right there. Therefore, there is no relationship between distance and time for that particular rock. Okay? This ultimately results in a y versus b type of equation. Distance equals wherever the hell it was to begin with. Okay? Now, if we go down and we look at something that is, say, directly related, meaning there is a nice straight line. As time increases, distance increases. Okay, again, if it's a nice straight line, generic form y equals mx plus b. Okay, so let's just say here that the slope is 10. We'll just say that, and that this y-intercept, let's not say that it's at 0. Okay, this isn't a 0, 0 point. We're going to say that this right here is 2 meters. Okay, so if I went to write an equation for this, and by the way, again, being a direct relationship, we would say as time increases, distance increases. Okay, I would write the equation distance equals, well, since my slope is 10, I'm literally going to write out 10, and then I need to add units to it. Now, the units for any slope are going to be the units of y over the units of x. Okay, whatever units are on the y-axis divided by whatever units are on the x-axis. So in this case, it would be meters over seconds. So this would represent meters per second, better known as a speed for us. Okay, x is what's on the x-axis, which in this case is time. And then we would have to add in our y-intercept, which is 2 meters. So I'm going to write 2 and put an m there. Okay, so distance is the y, 10 meters per second is the m, time is the x, and b, the y-intercept, is 2 meters per second. Okay, these first two options require absolutely no alterations to your graph. Okay, so in Logger Pro, if this was the shape of your graph that you got, you would literally have to do nothing after this. Okay, now if we had something that looked like this, okay, and this is an inverse relationship. As time increases, the value of distance decreases. Okay, this is not a straight line. Now, there is an easy thing you can do to get this to be linear. When something is inversely related, we have to graph 1 over x. Okay, so what is on the x-axis? Well, in this case, it is time. So if I graph 1 over time, if I make a graph that says distance in meters versus 1 over time, which would also be 1 over seconds. If I do that, you should get a nice straight line. Well, now that it's a straight line, it fits y equals mx plus b. Okay, but, and again, let's do this. Let's say the slope again is 10, and we're going to say this is 0 this time. If this is the case, okay, what's on the y? Well, what's on the y is distance. The slope in this case is 10. Now, the units for this are going to get tricky because you've got units of meters over 1 over seconds. Now this is a little refresher hopefully, but if you have distance over 1 over seconds, in order to get rid of the 1 over on the bottom, I'm going to multiply the top and the bottom. Whoops, that should be meters. Okay, I have 1 over seconds. I'd have to multiply by the inverse on the bottom and the top in order to get rid of it. That gets rid of this, and you're left with meters times seconds. So the unit here, meters times seconds, x is 1 over time. So instead of taking this and multiplying by 1 and dividing by time, I'm just going to put the time on the bottom. Okay? So what that also allows me to do is time is in seconds. There's a seconds above, so the times go away, and you'd be left with distance is 10 meters. Okay? Per unit time. And since this is 0, there is no y-intercept. Okay? All right. Let's try another one. Let's say you get a graph that looks like this. We're literally going to call this relationship y proportional to x squared, or in this case, distance proportional to time squared. If I want to change this so that it's a straight line, I need to graph y versus x squared, or in this case, d versus t squared. So if I take a look at what that graph might look like, and this is where you're going to be using your calculated columns, okay, in Logger Pro. If I graph d versus, s squared, which would give us seconds squared, I will get a straight line. Again, using y equals mx plus b, I should see something like distance equals, let's say the slope again is 10. You'd have 10. The units now are meters over seconds squared, which will be an acceleration for us down the road. Okay, time squared plus, and again, let's go ahead and say this was 2 plus 2 meters. Sorry, I ran out of space there. Okay, but all I'm doing is I'm using y equals mx plus b. Y, m, that's the slope, x listed down here for the x variable, and y is whatever our y-intercept is. Okay, so now we've gone through a no relationship, a direct relationship, an inverse relationship, an x squared relationship, and we got one more that we're going to see throughout the course of the year, and it's a y squared. So if I just got done squaring the x for an x squared relationship, you might be able to guess that for a y squared relationship, we got to square the y. Okay, so to graph, I'm going to graph y squared versus x, or in this case, d squared versus time. Okay, and if I do that, okay, d squared, that would give us meters squared, and time in seconds on the bottom. And we get a nice straight line. Again, to write this, it'd be distance squared equals, now in this case, again, let's just say the slope is 10, and then we've got meters squared per second. Meters squared over seconds. Okay, times time, and let's say this is 0. So I'm not even going to include a y-intercept if it's 0. Okay, so these are the 5 different relationships you're going to see, and ultimately what we want out of this is we want equations. Okay, in order to write a very simple equation, we need it in y equals mx plus b form, which is the generic form for a straight line. So get your data into a straight line with these 3 little adjustments. You only have to make adjustments on y squared, x squares, and inverses. Okay, but we're going to be doing this throughout the entire year, so get comfortable with it. This is how we're going to evaluate the relationships between variables. Okay.